So for the first question, it asks to use the convolution methods to solve for fz, where z equals to x plus y. And so we can see that we use this formula that fz equals to fx times fy. And then we know that this fc equals to the integral from negative infinity to infinity of fx of alpha times fyz minus alpha to the derivative of alpha. So we can expand this formula and know that also, first of all, we shift the result to right by 1. And we know that fc equals to the integral from minus infinity to infinity of fx alpha times fy z minus alpha derivative d alpha, and which is equals to negative infinity to infinity of u alpha minus u alpha minus 1 times u z minus alpha minus u z minus alpha minus 1 d alpha. It is from this equation. So we plug in these numbers and get it's like we expand this formula. So it's u alpha times u z minus alpha, which is this part. Integral from minus infinity to infinity from u alpha times u z minus alpha minus negative infinity to infinity of u alpha u z minus 1 minus alpha d alpha minus this part times this part, which is minus infinity, negative infinity to infinity, u alpha minus 1 times u z minus alpha d alpha plus minus infinity to infinity, u alpha minus 1 times u z minus 1 minus alpha d alpha. So this is the equation that I got. And we can expand this further on by plugging 0 to z, as we know that z equals to x plus y. So we change the impulse function and add in uz. So it's from integral of 0 to z of u alpha times uz minus alpha d alpha times uz, and minus this part, and then plug in 1 and z to this part, and 1 and z minus 1 to this part. So then we get this line, which can be further expand to z times uz minus z minus 1 times uz minus 1 minus the z minus 1 times uz minus 1 plus z minus 2 times uz minus 2. So this part is more like calculating. And we can get the final result line here. And the graph is here. This is for z minus 1, uz minus 1, and this graph is z uz minus z minus 1 times uz minus 1 minus z minus 1 times uz minus 1. And for the second part, we use the geometric method to solve the problem. So the first situation is z is smaller than 1, which is equals to the area of this part. And the big F is z squared over 2, and fx is the derivative of this part, which is the. And for second situation is z between 1 and greater than 1 and smaller or less than 2. So it's the area of this part, which is equals to z square over 2 minus this 2 triangle, which is 2 times z minus 1 square over 2. And the answer is minus z squared over 2 plus 2z minus 1. And fz is minus z plus 2. And that's it for this problem.